Have you ever wondered where your cache data goes when you're working with Spark? It's a common question, and today we're diving into the world of resilient distributed datasets, or RDDs, to uncover the truth about caching. I totally get it. When you're dealing with big data, understanding how caching works can feel overwhelming. You're not alone in this confusion. Many users have the same question about whether RDDs are stored in a distributed way or on a single node. Here's the specific question we're addressing today. One user asked, when we cache an RDD in Spark, is it stored in a distributed way or on a single node? In which system's memory is it stored? If you've ever found yourself wondering the same thing, stick around as we explore this topic. So, what happens when you cache an RDD? When you cache an RDD in Spark, it is indeed stored in a distributed manner across the cluster. This means that the data is spread out over multiple nodes, allowing for faster access and processing. Let's break this down further. And don't go anywhere. At the end of this video, I'll share a crucial tip on how to optimize your Spark applications for even better performance. When the user caches an RDD in Spark, it is stored in a distributed manner across the cluster. This means that the data is not confined to a single node, but rather spread out over multiple nodes in the system. The user should know that Spark uses memory for caching. Specifically, it utilizes the memory of the worker nodes where the tasks are executed. This allows for faster access to the data during processing. Additionally, the user can choose different storage levels for caching. For example, they can store the RDD in memory only, or they can choose to replicate it across nodes for fault tolerance. To check where the cached RDDs are stored, the user can use the Spark UI. This interface provides insights into the storage status of RDDs and their distribution across the cluster. In summary, when the user caches an RDD in Spark, it is stored in a distributed way across the worker node's memory, and they have options for different caching strategies to optimize performance. Fun fact, the concept of distributed computing dates back to the 1960s. It's amazing how far we've come and how tools like Spark make it easier to handle massive data sets today. Now let's look at the answers provided by other users. This user clarifies that when you cache an RDD in Spark, it remains distributed across the cluster. The cache or persist options do not alter the distribution of the RDD, so the data stays distributed both before and after caching. Let's take a look at an answer from another user. This user explains that when you cache an RDD in Spark, it is stored in a distributed way across the cluster. Each Spark executor has its own block manager, which acts as a local cache for the RDD data. The data is cached in the block managers that participate in the computation, corresponding to the number of RDD partitions. However, if the number of partitions is 1, the cached RDD could end up on a single node. The cached data resides in the memory of the Spark executor that manages the RDD blocks. Here's that crucial tip I promised. Always monitor your Spark application's memory usage. This will help you optimize performance and avoid running into memory issues down the line. And there you have it. Now you know that cached RDDs are stored in a distributed manner across the cluster, utilizing the memory of executor nodes. If you found this video helpful, please hit the subscribe button for more insights on Spark and big data. And remember, optimizing your applications can lead to significant performance gains.